Let's continue our discussion of the matrix U, where U has octonormal columns and this U has n columns and m rows. So it is a m by n matrix, and the columns of U are orthogonal to each other and has length 1. So they are octonormal columns. When a matrix U has these properties, there are several interesting that will happen. U times x is length is the same as x. That means performing transformation using U preserve length of the vector to be transformed x. Ux dot uy is equals to x dot y. It preserves the relationship, the dot product relationship between x and y. So transforming x by ux, y by uy, and dotting them is the same as x dot y. And in the transform vector ux dotting uy equals to 0, then this will only happen when x dot y equals to 0. So we say that performing linear transformation with u on the vector x preserve the length and the orthogonality and angle between the vectors after the transformation. Let us have an example. In this case, u is a 3 by 2. So this is u1, this is u2. You can show that u transpose u is octonormal because we will get the identity. And then now we are going to take u performing a transformation on x through u by x. U is a 3 by 2. Therefore, x must be a 2 by 1 vector, resulting in a 3 by 1 vector. We transform a R2 to a R3 vector. This is the brute force computation. You can try it by yourself. And now, once you have found this is ux, you can find its length simply by taking these values and then finding ux transpose ux square root. Basically, the entries are squared, so this is 9, this is 1, because minus 1 times minus 1 is 1, 1 times 1 is 1, so we are summing the square and performing the square root. This is the length of ux, and then we can also compute the original length here. So this is square root 2 square plus 3 square root is 2 plus 9 square root 11, showing that as expected, performing a linear transformation on x by u preserves the original length of x. Next, we extend the idea of u from a rectangle to the special case when u is a square matrix. That means we have a square matrix and we have octonormal columns. The columns of the square matrix are octonormal. In this particular case, such a square matrix is called an octogonal matrix because its inverse is equals to the transpose, because u transpose u equals to I, u transpose equals to I, because an inverse matrix is u minus 1 u equals to I, u minus 1 equals to I. That's the idea. So an octogonal matrix is a very special matrix because its inverse is simply its transpose. You can take a look at the Wikipedia definition. An octogonal matrix has octonormal columns and it is a square matrix. Now, so there are some confusions to the word octagonal matrix. First, remember that octagonal matrix must be square. So if a matrix U only has octonormal columns, there is a, for example, it's a 3 by 2 in our previous example, the two columns of U are octonormal, it is not an octagonal matrix. We simply can just say that it is a rectangular matrix with octonormal columns. It has no special name. The special name comes when this rectangular matrix becomes a square matrix. And when it is a square matrix, then it is called an octagonal matrix. Now, but please remember, if U has octonormal columns, it will have two properties. U transpose U will be the identity. The dimension will be n by n if it is originally an m by n matrix. UU transpose will be m by m square matrix, but it's not equals to identity. It is a projection matrix with rank n. Okay, that's all we have. Thank you.